Tom Hagen is going to talk about LoFASM data analysis tools running under Windows Subsystem for Linux and a how-to guide. Tom has been a member of SARA since 2010 and is a retired electrical engineer, having worked in the area of automotive electromagnetic compatibility. Tom likes to promote amateur radio astronomy by trotting out his hydrogen horn of plenty radio telescope at Detroit area star parties, and teaches programming classes in his local public library. Tom lives with his wife Kathy and cat Anna in Rochester, Michigan. And Kathy used to be the journal editor, because that's where I first published a couple of my articles with Kathy directed me how to do the editing. Okay, Tom, it's all yours.
Okay, can you hear me?
Can, yes.
Okay, I'll try sharing my screen next. All right, well, I see we have 50-some people left for my presentation. Thank you for sticking it out. And I thank Sarah for letting me give another presentation this year. So I've been working with this LoFASM project now for several years, on and off. And I became acquainted with it originally through a contact to Professor Tim Dolch at Hillsdale College up here in Michigan, in Hillsdale, Michigan. And he is a physics professor there. He's built a LoFASM array. And this is part of a project that consists of 5 stations consisting of these 12 low frequency arrays, low frequency antennas, dual broadband dipole antennas that just discussed a few minutes ago. So today I'm going to talk about, in order, what is LoFASM? How do you set your PC up with Windows Subsystem for Linux version 2? How do you download and display data? Well, we probably won't get that far today. Eventually, when I extend the project, I want to move ahead and actually get students involved looking at the data. The data has been accumulating now for 5 or 6 years, and I don't believe anybody has actually gone through it. So we have 5 years worth of data that might be hiding fast radio bursts or something. We don't know. So in the interest of STEM, I'd like to develop this project into a program where we could get maybe high school students to load up these LoFASM data analysis tools and start looking through the data. So I kind of stole the name LoFASM Zoo from the Citizen Science Galaxy Zoo project. Everybody is probably familiar with that, where people can go online and look at pictures of galaxies from many, many different observatories, as I understand it, and look for anomalies and point these out to the experts. And so, you know, everybody benefits. Maybe we can do the same thing here. I don't know yet. It's a work in progress. Helping me today is Ed Harfman. Ed's been invaluable in working out this process. So the paper basically is about how you start from scratch and set up your Windows 10 PC to analyze LoFASM radio astronomy data. So anyway, LoFASM is a very small system. It consists of 12 of these low frequency dipoles that are used in a number of different projects, most notably at the long wavelength array out in Socorro, New Mexico, made up of 12 antennas arranged in a Star of David arrangement. And we have dipole orientations in the north and south direction. These are all 12 oriented the same way. Then we have dipoles arranged in the east-west direction. So in the middle here, you can see in this picture, you can see the combiner box that takes basically 24 signals, 2 each from the 12 antennas, and combines them into 4 output signals. which are we have an inner circle here and an outer circle. We have inner circle north-south polarizations. These are combined. Then we have inner circle east-west polarizations combined in one signal. And then we do the same for the outer circle. So we have 4 signals coming out, and they run through cables about 1,000 feet back to the control shed. This site here is the one in Hillsdale, Michigan. There's 4 other locations scattered around the country. There's one out in Owens Valley. And then there's one at Goldstone, another one at Green Bank, and then the original one was down in the tip of Texas near Brownsville, Texas, and it was put together by the University of Texas at Brownsville down there. Operates in the range of 10 to 80 megahertz. This system is, when it's up and running, runs 24/7, scans the sky. Intent is for detect fast radio bursts. And the idea, of course, of having multiple sites around the country is so that we can rule out local RFI events. The beam itself at 20 megahertz is about 20 degrees wide, pointed straight up. And let's see a little bit more about the antennas. Here we have the 2 orthogonal orientations, polarizations. We have a preamp up here, dual preamp. So we have 2 cables coming out of each antenna, carrying the signals from each of the polarized pair of antennas. So LoFASM then uses correlator. It uses the Roach board. That's pretty commonly used to gather data. Data is taken in 5-minute chunks. The frequency range here, as you can see, is 15 to 88 megahertz roughly. And this is a waterfall display. Here's time. And then versus frequency along the bottom here. As you can see, we have a lot of RF junk here and there. You can see it in the slice up here. If I had an active window here, I could actually move my cursor around here and you can sample the RF spectrum here. So this would be one method, one of the tools that we could use to actually detect spikes, RF bursts. But I think, once we start looking at these, we should just be able to look at the, the waterfall display here and see a burst. Some of the results so far, that I've seen, we have, here's one at around 50, 55, 56 megahertz. Looks like a man-made signal, a sideband signal of some kind. We have 2 plots here, 2 different time scales, I imagine. So a radio burst might look something like this, but of course, somebody has to look at it and then flag it, and then somebody else needs to take a second look at these flag plots to see if they are RFI or artificial or what. So anyway, what we're going to do is we'd like to show, this is from this point on, basically it's a very detailed how-to procedure on how to start from 0 to on your Windows 10 laptop, how to install first Windows Subsystem for Linux version 2, and then the various LoFASM tools that are available on the GitHub site out there, and then use it to inspect some data. So what I'd like to do here is stop share and then hand it over to Ed Harfman, who's going to take over.
Okay.
Ed, are you ready?
I am ready. hopefully you're seeing my whole desktop. And I've got Tom's slide deck over here. So, and I've got a number of little things here to help me remember things. So WinVer started up, and I'm running on newer version than what is required to run the Windows subsystem for Linux version 2. And
Yeah, you need at least 20.04, right? Or
yeah.
higher.
So if you've got Windows 10 and you've basically kept it up to date to this past spring, I believe it will be able to run this very well. I'll add the comment that there are some things that Tom's got in his paper to ask you to install. The fall release of Windows is going to get rid of the requirement of installing an X server that is supposedly going to be built into the system. So let's see here. If you go over to the Microsoft site, it basically boils down to 3 commands here for you to get it set up. You go through, you run DISM to install the Windows subsystem for Linux. Yep, oops. I knew I was going to forget something. You're running this as an administrator. So I'm probably going to do that a couple of times today or this afternoon. So you run this. Okay, I move this down so the controls from Zoom aren't biting me. It goes, yep, and the feature's trying to install it, and it's going to come back and say it's already installed. And he's happy, everything is gone in there. Tell it to install the virtual machine platform. And then the final command here, WSL, which is their nickname for Windows Subsystem for Linux. Set the default version to version 2. Version 1, yeah, it worked, but there were issues with programs that used graphics and so on and so forth. So just generally, if you're ever going to run a Linux subsystem for Windows, don't bother with trying to install or run it with with version 1. Default it to version 2. So then you just bring up the I don't know why this has been kind of a flaky. All right. Of course it has to mess up. I'm giving a presentation.
Yeah, Windows Subsystem for Linux is an actual kernel, a Linux kernel that runs on your PC. It's not an emulation, as I understand it.
Right. So then you go on to the Microsoft Store, and we've been working with the Ubuntu 20.04. LTS is long-term service. And normally you would have to say, yes, I want to buy it for free, and then install. Fortunately, I've got a substantial pipe running into my house here, so it's here and able to download that rather quickly. If you're running that over a smaller internet service, that is going to take a minute or 2, or 3 or 4 or 5. So the machine starts up, and you can type in any name that you want. I'm just going to keep with my own name and a real password on here, because this machine is able to go see the internet, and likewise the internet can see this. So anything I do on this machine subjects me to potential issues, but I'm not going to leave this running all the time. So I'm going to do everyone here a favor, and properties. Okay, I bumped up the font size. This is as big as I can make it, so I hope you can see it. First thing I'm going to do is go in here and run a program called Nano, which is an editor. .-rc. And I'm just going to go to the end of this file and do a little bit of enter one command that is going to make the X client, which is running in Linux, communicate to my desktop, which is running in an X server. Now,
This script runs every time you boot up, is that right?
yeah, so that means that every time that you start this Linux shell, it will know to connect up to my desktop for displaying any graphics. So save it to that file. And now, since I've edited the file, but I haven't run it yet, I'm going to exit out again. Now I'm going to start up Ubuntu, and there he's running, and now he's got that X server set up. In the paper, in the Tom recommends Xming, and at the time that he had written this, Xming worked correctly with this. I'm guessing Microsoft broke something. My first guess is probably it's in the antivirus, but who knows? Xming doesn't work today. There is a different program which actually, now that I've started using it, is better. It's called GWSL. It is an X server as well. Yes, I want to allow it to access my desktop and my private networks. Okay, he's finally up to life. Actually, I'm just gonna go in this way. Don't show that again. That's something new. Okay, this is the thing that I like about it, is that it has a series of nice little options here to start, including being able to use Windows Explorer to transfer files on and off of the Linux machine. Okay, so we're done with script 1, and I need script 2, which unfortunately is somewhat involved. So before we can get to the point of installing the prerequisites for LoFASM, the people who distribute Ubuntu have pulled out Python 2, which is what the LoFASM tools are written in. So we need to go through and install those.
I heard that support was ending for Python 2. Is that a bad thing?
As long as you've got applications that never have to be touched again, and you're not going to be pulling in new versions of the library, then no, it's not a problem. On the
Okay.
other hand, the libraries get updated or anything like that, chances have it that the whole thing is going to have issues, and you're just frankly better off to contact the authors and say, yeah, you need to update your software to a newer version of Python. Okay.
So hopefully they're using these tools too, and they'll have the same problem.
Yeah. So I'm just going to go from being me to sudo says give me super user permission and run the program bash, which is their command program, which allows me to stop typing my password every 5 seconds. apt add repository universe just says, okay, we need make sure that the universe repository of software is available to us. apt update is going to reach out to the internet and go get the latest list of applications that are available for this version of Linux. apt install Python 2. Say, yes, I want to install it. We'll pull down all the pieces, install it, configure it, and now it is ready to run. Update alternatives. Is letting us go through and tell Linux that if I just type in Python, I want to use the Python 2 version, at least it will, as soon as I do this last command. And no, I can't walk and talk at the same time. I have to, I'll either type or I will copy from the wrong line here. See, I was talking. Two dashes. Okay, so now I entered number 1, which goes through and says option 1 here is the default. So it's going to start Python 2.
Quick comment, Ed. Louis Dartez, the author of the software, recommends installing this in a virtual, what they call it, a virtual version for your Python setup. I think that would probably avoid a lot of these problems. Plus, other Python tools that you try to use wouldn't get confused.
Okay.
We might look into that later.
Yeah. Well, this is what we figured out here recently. So this is the best we got today. Yeah,
it's work in progress.
Yeah.
Hope everybody understands that.
Yeah, and Tom will have a copy of these scripts that I'm working off of, as well as additional information. As I figure out things, I will work with him to go through and make sure that they get updated correctly. apt install curl. Curl is a little utility that lets you go through and pull down any file off of the internet. All you have to do is give it the right path. So when I do curl https bootstrap py.io pip 2.7 get pip py. So it just pulled down a script to go get and configure pip for which is the utility to go and install a lot of these utilities that LoFASM are based upon. Okay, there's one last thing that we need to install, and then everything else is directly related, which is TK, which is a graphics toolkit. Toolkit is what I call my toolbox out in the garage. It's a graphics toolkit that would go through and allow you to do displays of graphics, nice charts, all the other fun stuff that you like to look at, as opposed to the old ASCII charts that we did once upon a time and thought those were cool. And this one takes a little bit longer than the rest. I'm not sure. I think this is the longest one that runs. So now, these are the tools that are actually required by LoFASM. So we'll install SciPy. Now I'm going to go ahead and do it just to show that no harm is done, but NumPy was installed right here. And it just says, yeah, it's already installed.
One less way to break it.
Yeah, well, it does not break. The system is fairly resilient that way.
Yeah, yeah.
Matplotlib is a nice little set of utilities to go through and get the make some more standard plots. You know, it already has certain layouts all set up. Now, in order to get the LoFASM tools, we need to get Git. Git is a website that's out there. It is a source code repository. It has literally tens of thousands, if not hundreds of thousands of projects that are on there. They allow for collaboration amongst different authors. It is, you know, for people who write code, it is a very, very, very good system to work with, in that it keeps track of all the changes and lets you go through and say, who checked in this garbage, and allow you to undo that damage. So it's out there, and that is where his source code is located. So all we do is git clone https hub.com ldrt3z lofasm.git. Okay. Next, we need to install, and okay, we don't have it clipped onto that slide, but you need to cd into the LoFASM directory. Python setup.py install. Oh man, that just takes way too long. LoFASM plot -F/user
Yeah, about 10 minutes left.
home ed LoFASM test data 2015.
So this is a test file that's comes down from GitHub. This allows you to test your installation. If you see this display scrolling like this, you've done your job correctly.
Yeah. So if this pops up, you're most of the way there. I mean, now you can start looking at the data and try to make some sense of it. So this goes on for about a minute on my machine. And it has stopped. Okay, so this screen. Now, Tom's got a nice little description here of what these different, yeah, kind of hard to put both of them on the screen at the same time. So, Tom, if you want to go through and describe this.
Sure. We have, as I mentioned earlier, that we have 24 signals coming off the 12 antennas, and they're grouped into north and south inner circle, east and west inner circle, and north and south outer circle, east and west outer circle. So basically we have four signals that are combined in the combiner that's out there in the middle of the array in the ground there. Four cables go back to the equipment shack and ultimately to the correlator. And then we have basically 10 possible correlations among the four signals. You've got 4 auto correlations, inner north-south, inner east-west, outer north-south, and outer east-west. And then you've got the correlations of all the possibilities of the individual combinations of the four signals, inner north-south times inner east-west, and so on and so forth, all the way down. So you got 6 of those and 4 autocorrelations. Then they take these, the system takes these 10 signals and forms the beam and basically runs 24/7 logging data. Each station logs around 35 gigabytes per day or something like that. And as I understand, the data is just piling up. Nobody's looking at it. So I'm thinking, hey, this could be fun for high school students or something. So that's kind of the level I'm gearing it to. And of course, anybody else who wants to help out is most welcome. I think we have one more slide. So anyway, yeah, next steps will be to develop a structured system to go through the data on an orderly basis to search for transient events. I'd like to roll out the program to schools, clubs, individuals, and maybe Sarah would like to take this on as an outreach program to promote radio astronomy. Who knows? Thank you for your time.
Okay, great. This is going to be fun. I got one question from Ron. What is the advantage of using WSL instead of the dedicated Linux operating system? Doesn't WSL add computational overhead?
Well, the advantage is everybody's got a Windows 10 PC. So, as opposed to trying to set up everybody's laptop as a dual boot machine, I'm thinking this is an easier way to go because, you know, this way Ubuntu just appears as just another icon on your taskbar down there. And as I understand it, again, it's an actual kernel, and it runs. I think it runs about as fast as it would on a dedicated machine. I'm not sure, but I think it does. It's really fast for me, and I think it's fast enough for this purpose.
I run virtual machines all the time for work. If your desktop really isn't doing anything other than doing mail and everything else, you're not going to notice much, if any, performance hit over having it installed directly onto the hardware. So you've got it. If you see more than a few percent of a performance penalty, I would be surprised. I see the last one added there by Jack. Is Windows required to run the tools? The answer is no. This can run on Linux, and actually there are ways to go through and set up Python and all of these other toolkits on Windows itself. The problem that people run into, though, is that Linux is a case-sensitive operating system and Windows is not. So some of the authors of software have not been too careful, and they'll have the same file name with different case between the different files. So I do not know. It might be possible to run. I know that I've got several applications that run under Windows that use Python. GNU Radio is one of them, and they work just fine. So I would think this probably could work directly on Windows as well. Haven't tried it. Maybe one of these days.
Okay.
Yeah.
All right. Excellent. And we did have a problem with Windows, or excuse me, Python 2 and 3. They're not the same program, and they don't. The same commands have different issues. So
yeah, they're
so
totally different things, totally different animals.
Okay, here's another one from Bob Strickland. Have you tried to look at database to math any published transits which were recorded by others? I'm not quite sure.
No, I haven't gotten that far yet.
Okay.
What site was that?
I asked a question. I meant to say match, not math.
Oh, okay. Why don't you go ahead and ask it directly to Tom so he can.
Yeah, I was just wondering if the data exists there. If you're taking a look at it to try to find during any other transits that other people have published that they've seen. If you could dig into this database to see if you've got any anomalies around that same time frame.
Yeah, that'd be an excellent, good thing to check out early on, because we're probably going to have to look at thousands of files to see anything at all. I see Chip's asking about Raspberry Pi 4. I don't see why it wouldn't run on Pi 4. It should run quite well. I'm running a Pi 4, and it's not too bad, actually.
It'll run just fine on a Raspberry Pi 4, but two things. First off, part of the WSL version 2 is that it allows access, some limited access, to the graphics coprocessor that's on most machines these days. And I believe the software does take advantage of that. Now, there is a coprocessor on a Raspberry Pi 4, but the processor and that graphics coprocessor are nowhere near the class of what a laptop or desktop are capable of. So, will it run? Yes. Will you be thrilled at its performance? Probably not. If you're not that fussed about the performance, then yeah, you can go for it. I don't see a reason why you couldn't and shouldn't.
Okay, is that everything? All right, well, thank you very much. Great demo.